All right, so hello everyone. My name is Daniel Balog. I'm with Team Luciad. Here's some other people who joined them in Team Luciad. They're mostly people who work at Team Luciad, except for Pierre Marchand. So I'd like to give some special thanks to him for joining us and helping us with a lot of data. Thanks a lot. We've never been at a hackathon before, so this has been a fantastic experience. If it's always this nice, my God, then I look forward to the next one. Next slide, please. So let me just give you a quick introduction on who we are. So we're software developers. We work here in, we work in Leuven, I should say. And we focus on geospatial visualization. So I know a lot of teams were focused on predictive models and things like that, but we focus on visualization and interesting things that you can do with visualization and the applications of visualization. So if you go to the next slide. What are we doing here? Well, first and foremost, let's do some hacking, right? That's why we're all here. Well, actually, there were two reasons why we came here. First, we were involved with the academics of the Rega Institute in the KU Leuven. We did some research for visualizing Ebola, hepatitis C, influenza, and things like that. So we thought this might be a nice progression. And our secondary goal is to assist anyone with visualization. We've helped a few teams, I think Team Diversity and the boot campers. We're happy to work along with us. If you go to our next slide, so what did we try to do? Well, we're not going to focus on predictive models because that's not really our domain. But instead, we set out a goal, and the goal was, let's take all the data that is available on our very nice Exavault. Let's take the weather data, let's take the livestock data, because there's some cows and sheep and stuff in there. Let's take the population data and the dengue outbreaks, and let's just put them all together, do some correlations, some visual analytics, and let's see if we can see there are any signs in there, if there are any correlations. And then using some tools, we can use GPU acceleration, we can do all kinds of cross-references, and the idea behind it was, what if we take all these parameters and we tweak all kinds of sliders at real time and then detect if there's a correlation between dengue outbreaks and then specific parameters, maybe even parameters that you wouldn't expect at first. Of course, this was a very ambitious goal to create a tool that can do all of this. So did we succeed in our cause? No, but I would like to show you some of the results that we achieved in this short time. And I'm losing my mic here. If you could switch to the video. The first video in VLC, please. So when we arrived here on Friday, we started from scratch. We started importing data, and then we wrote a tool to visualize and kind of correlate it into each other. So what you see over here, there's a part of the screen missing, but that's okay, is us scrubbing through the data, looking at monthly precipitation reports, looking at dengue outbreaks, which is visualized over here on the map with various indications of severity, but also here on the time slider, where you can see how many people are infected. This is Malaysia, which had the outbreak cumulatively over a period of time. We reverse queried that to see the actual outbreak numbers. And then we tried to correlate that with also daily precipitation to see if we could spot any patterns. Of course, going further, we wanted to do way more. So if you could show the second video, and I should apologize for the second video in advance. It was taken half an hour before submitting the presentation, so it's recorded on a phone. The final idea was, what if we could take even more data sets and combine them in a way? So, yes, so what you see over here is precipitation. Again, this is a different styling. We can kind of move through the data. We can switch to temperature overview. But what we can also do on the fly, which is what we intended to do all along, is combine these data sets to find areas that have high humidity and precipitation, but also high temperature at the same time, which is then visualized in these red areas. And then we can also scrub through the data, tweak the parameters on the fly, and we get these results. And the idea was, what if we could correlate this with dengue? Maybe we could also predict other outbreaks later on using just visual analytics. All right, if we go back to the slides. All right, so some of the conclusions in the next slide. What are the further steps? Well, obviously we need more time. We would love to spend more time on this. I think that there's some very fascinating data here. But also I would like to stress one point that we learned. We spent the last 36 hours going through Excel sheets, going through all kinds of messy, unclean data. And I would like to stress the importance of standards in general. I feel like that if we had a good standard that we could work on and work together with, developing applications would be much faster, and you could spend less time going through and cleaning data, and perhaps actually developing applications and cool tools that allow you to fix problems in the future. It's just a conclusion. You can still keep working, of course. That's it for me. If there's any questions, I'd be happy to answer them.